Right, this is going to be our first run, or first video run, of our inertia drive, or RFDD as I'm calling it. As you can see here, I'm having some dramas with the cables snapping after a couple of minutes run time. So put some heat shrink tubing over the cables so as to try and stop them chopping out like that against our satellites. And of course these cables are what carry the satellites. So but anyway, we'll give it a run, see how we go. At the moment I have it swinging off the roof for our pendulum test, and even a slight breeze makes that move, because if the wind blows the shed moves a little, and so does the timber holding the shed. So but anyway, it's suspended up there. Now you'll see directly behind the cables I have three little marks. The middle one lines up dead centre with the two cables, and then of course we have one each side, so we can have a look at that as we're having a look at this line here and the one on our little stick that's screwed to our device. So that's our setup. I'm going to now go and mount it on our little tripod there, so there'll be no movements of hands. We'll, that's a speed controller, by the way, running off the battery, which is being charged by the charger. Now that simply goes around the back here and upside down shot hooks into our power supply for our motor. So that's it at the moment. Swings nice and freely. And like I said, if the wind blows on the roof, the beam moves slightly, and so does the stick down the bottom, but it looks like the wind's taken off. I've been waiting for a couple of hours for it to die down, and seems all good so far. So next we'll set the tripod up, get it placed very steady on that line down there. We'll do our test run, see what happens, and then I guess you all want to have a look what's inside, don't you? Well, that's what I'm going to do. I'm going to show you inside how it works, and I guess we can all take it from there as to what we do with it. It can be made much better, much more efficient, out of much better parts. This is just a proof of concept deal, so let's see how we go. Okay, I've just got a white bit of paper up there now with the black marks on it. Hopefully they're a bit easier to see. So just kick her in the gut, see what happens. It is noisy, but I'm sure a newer model could be made to be a lot quieter than what this one is. Okay, here we go. Oh, no, here we don't go. Wait a minute, something's stuck. What's going on here? I see the problem. Not so good. The cables jump behind the hooks. Okay. I'll have to give her a bit of a harder start than that one. Sorry about that. Right. It's moving a little bit, but not much, so we'll try again. of that because I want to, like I said, take the lid off and show you the insides of that. Not as much deflection as I'd hoped for, but very small satellites we're using too for such a large unit. So we maybe got an inch on the pendulum, and that was about it. I didn't show you the white lines, did I? Alright, we'll start it up again and hopefully it'll all stay together. That's about it for this one. Not a lot there, but there is some. So now we're going to have a look inside, see what actually makes it work. Not sure if you would have been able to see those white lines up there, but hopefully so. Hopefully so. A bit hard to see the camera angle down here, squatting on the ground, but anyway, let's go pull it apart and have a look inside. I've just about stripped this thing down as far as I can. They're all the panels that I've taken off to expose everything inside. I've had to put two braces in here to stop the whole lot wobbling because there's nothing holding each wall up now. So let's have a look inside the machine. But before we do that, let's just go through the operation of things inside first so as you understand what's going on. We have our 4 satellites. Here we have the centre shaft that is driving these satellites. Now at this point, satellite 3 and 2 are in equilibrium. Please don't take too much notice of my orbit, it's not very good. Satellite 4, which is the furthest distance away from the shaft, is the one that's travelling the fastest, which means that it has the most force that way. So in this case, with this machine here, the force is in that direction, which you would have seen in the video. Okay, now the interesting thing, along with that being one forward force, when you see the machine operating, I want you to take very careful note of the satellite that is closest to the shaft, and you will see that, I haven't quite drawn that properly, sorry. This satellite actually takes this path here. And it's going to take a few of you brainiacs to work out why. So that one's actually in there. So it basically starts turning the corner and goes straight up. And that takes a bit of nutting out. And that has to do with the way that the system is set up. To give you a quick little sample, so we had Bill the Stickman here. Let's get a new bit of paper actually. I know I'm boring you to tears, you want to have a look inside the machine, but there's no point looking into something if you don't know how it works. Okay, we have Bill the Stickman here, and we have Ted. Yeah, why not Bill and Ted, eh? Their excellent adventure. The Stickman here, and they're holding a bit of rope, like yay. That bit of rope has a ball in it. So what happens when Bill pulls this way, Ted pulls that way, the ball here goes that way. And that is what happens here. As satellite 4 is travelling down towards, where's our number gone? Satellite 3, the cable, or in this case our string, is being pulled tight and the ball starts to shoot upwards. And as it starts to leave and the wire becomes loose, which is these shitload little broken cables here, our ball now starts to go straight up until such time as the wire starts to get tensioned again at this point, and it pulls the ball back into an elliptical orbit. So that's how that works. Once Ted pulls that way, Bill goes that way, the cable then becomes tight, and our ball that was here is now on its way up. So that's how the system is designed to work. I didn't quite expect the effect to be this great on this side. So what that means is this ball here has no force directly backwards. It actually has a slight force forwards because of the path that it travels, which you will see when the machine's running. And this ball, of course, also has a force out that way, which starts from this point, satellite 2, satellite 3 is that way, and then the force is divided up, and its maximum force of satellite 4 is a direct horizontal path from the shaft, or when this is out, as far as it can travel. So enough on that, I guess. We'll go and have a look at the machine now. Kept you waiting long enough, I guess. And I wasn't going to show how it works until someone that I'd chosen had replicated it. However, I'm just going to leave it all up to you guys that like building to build it and have a look yourself. Of course, there is more tests to come. Like I said in the first video, I had a bit of a head start on it because I've already built one of these devices on a smaller scale and done various tests. The pendulum test, weight loss test, in the way of a buoyancy tank where we set the device in a tub, measured the water level on the tub, and then we started up and the water level dropped on the side of the tub, all around the tub. So not much. That one wasn't quite as big as this one and didn't quite have as much effect, but it showed me that the principle was there to make it work. Alright, let's go and have a look at the machine. There we go. First up, before we have a look in there, this cable is a stainless steel stranded cable. This is it here, 90 pound test, or 41 kilograms, and it snaps it like carrots. There's an extreme amount of force on the satellites bringing them back into a close orbit, and that's that sideways force I showed you with Bill and Ted there. Even though the sinkers or the satellites are relatively small and lightweight in regards to the size of the device, there's a lot of force there. So if you're going to build this, make sure you cover them all up, because if you get hit in the head with one of these, it'll be just about show over. Alright, so here we go. Here's our setup inside. As you can see, or can't see, I can't take it apart any more than this, otherwise there's just absolutely nothing holding it together. So here's what happens. We have our two pulleys that run at an angle here. So at this point here, this cable is relatively tight, which brings our satellite into a very close orbit to the centre of our shaft, or the centre of the device, but you'll actually see that this one is actually pulling towards the same direction as this one here, which is now loose, throws out. So you can see the distance between there and the centre of the shaft, and the distance between that one and the centre of the shaft. So we have a greater distance, which means this one produces more force in that direction. And this one here, when you see the machine run, you should be able to see, I can see with my eyes, hopefully we can with the camera, you should be able to see it actually taking that sort of a path. So it is noisy, and I've had to gear this thing right down because if I go any faster, those cables just don't hang on, they snap. The reason they're so small is so I can try and make them flexible enough that the satellites don't get the wobbles up. I tried a thicker cable and it didn't work as good. So the efficiency of this device, that's already chewed out the heat shrink I've got on there. I think it's actually the corner of the sink is cutting the cable maybe. But anyway, hopefully one of these won't break when we're running it and hit my camera or me. So I'll start it up. You'll see this one fly out there, well these ones will be out here. This one here you'll see actually in like that, which means it has absolutely no force that way fighting against the force that this one's producing. So the cables don't feel frayed, but I guess we'll find out soon enough. Now what happened last time when it locked up is this actually went right to the back of the hook and tried to pull straight across, which is another headache with the design. I've already been thinking up new designs, and I already have a lot better one than this that uses steel straps with weights on it and a resting disc in the middle. Okay, here we go. So we'll crank her in the guts, hopefully it'll start first time, everything looks alright, and wait for the noise. Like I said, make sure you have a look at what this one's doing. It's actually going opposite to where it should be going. Okay, so there you have it. I tried to get that in shot as best I could around the device. It'd be nice if we had a hole in the side here we could have a look through, but I'm pretty sure you could see that this satellite almost took a vertical path with a slight inwards dip, and it was very clear to see that this satellite was way up there. Now the force pulling the cables tight is of course due to the growing distance on the pulley, so it's a pull force both in this way and that way, and then of course once that distance starts getting smaller, the satellite starts to grow outwards, as you can see there. So our force starts from about there, and this force of the satellite on the bottom throwing out pulls the inside together as well, and the force on the top tightening the cable is a pull inwards on the two pulleys as well. So we have an inwards force on top and bottom, which is basically just trying to crush the box. But Of course that's not going to happen when we have it all braced. So as you can see, very small satellites. We could do much better than this, but at the moment that's pretty much all I can do on a week off, along with all the other jobs that I have. So not much more I can show you, just our little motor. You can see I went for the old girl out of the scooter. It's much more efficient than that new one I bought. And just our reduction drive via chain and sprocket. So that's about it, guys. Nothing more to it. And not much more I can show you with the device.